So what we did in the first video was you were checking to see if a point was actually a solution to a system or if it was not a solution. Now we're going to talk about how many solutions a system can have. Okay, so you can have one solution in a system, you could have no solution in a system, or you could have infinitely many solutions in a system. Let's look at an example where a system has only one solution, and this is what you have seen in 8th grade. You saw a system on a graph and you found the solution, and hopefully you'll remember that the solution is found where the lines intersect. Where do they cross? Where do they meet? Okay, so we have two lines that are graphed on here, and our solution is where they cross. So where they cross is this point right here. And remember what we said earlier is that the solution to a system is a point. Well, every point has an x and a y value. Okay, so this specific solution to this specific system is going to be 0 because we didn't go anywhere on the x-axis, and then up 2, so 2 for the y value. So the solution to this system is 0, 2. Now let's look at a system where it has no solution. So this one has no solution, and notice that the lines are not touching. They are not intersecting, they're not crossing. Therefore, these lines are parallel lines. So if you ever have two lines that are parallel, then that system has no solution. We also say that a solution or a system that has no solution is called an inconsistent system. The last option is that your system has infinitely many solutions. So notice on the graph you only see one line that's graphed, however you see two different equations that are in two different forms. Now if we got these both into slope-intercept form like this one, then the equations would look exactly the same. Okay, they are graphed, you only see one, but they're technically graphed on top of each other. It's the same exact line. So when the lines are the same line, then they have infinitely many solutions. And this also has another phrase for that, and that would be a consistent dependent system. So let's review this real quick. A system has one solution when the lines cross, or in other words, when they intersect, and the solution is that ordered pair, that point, the x and the y value. A system can have no solution when the lines are parallel, and that is also called an inconsistent system. And lastly, when two equations create the same exact line on a graph, it has infinitely many solutions, and it is also called a consistent dependent system. Now let's try number 3. Number 3 says to use the graph to solve the system of linear equations, and then we need to check our solution. So they've given us two equations, and together these equations are a system. And they've actually given us the graph for both of these equations already. So think about it. Are these lines crossing? Are they intersecting? Are they parallel? Or is it the same line? Well, these lines are intersecting, so this means it has only one solution, and that solution is found where are they crossing. So we need to figure out what is that ordered pair. Well, starting at the origin, we went over 1, so that would be our x value, and then we went down 1, 2, 3, so -3 would be the y value. Actually, we went -1. I forgot to write the negative. So our solution is -1, -3. But now we need to check it. How do we check it? Well, that's exactly what we did on the first video in numbers 1 and numbers 2. And we took the x value and the y value and we plugged it into both equations. So let's do that now. So here are both of the equations with the x value plugged in and the y value plugged in. Okay, so now we need to simplify both of these and see if we get a true statement for both of the equations. If both of them are true statements, then yes, this is the solution. Hopefully you pause the video and simplify this to see if you could do it on your own. But what I got for the first equation is that 5 is equal to 5. Well, that's a true statement, so that equation checks out. And for the second equation, I got that -5 is equal to -5, and that also checks out. So because both of the equations ended up being a true statement with the same x and the same y plugged into them, then yes, this is a solution to our system.